Hi to you watching this video. So welcome back. For this video, we're going to discuss about equilibrium and the analysis of structure. So we'll be solving problems related to those two topics. So we have here number one, determine the horizontal and the vertical components of the reaction on the beam caused by the pin at B. So we have a pin connection at B and a rocker at A as shown. So neglect the weight of the beam. So since we're going to neglect the weight of the beam, we're only going to consider these three forces present. Okay, so to start with, we need to draw our free body diagram. So if this is my free body diagram, what are the forces involved? Since this is a rocker, we only have one reaction at A, and that is vertical. So that is a vertical. Next, we have a pin connection at B. So since that is a pin, we can expect that there will be two reactions. So we have here the B vertical and we have here the B horizontal. Then we have here the 600 Newton, which is inclined, that is uh, inclined 45 degrees from the horizontal. So we have here the 45 degrees. And it has a distance of 0.2 meter from uh, point A. So that is 0.2. And we have here the 100 Newton force. And we also have here the 200 Newton force. So these three forces are the forces present in our system. Okay? So we can now solve. Let's first place our distances. So what are the distances? So we have here 2 meter, 3 meter, and 2 meter. Okay? So using the equation of equilibrium, I'll be having my moment at point A, then I can solve for the B vertical. So summation of moment with respect to A is equivalent to 0. All forces that are rotating clockwise are to be positive. So what are those? So we have the vertical component of 600 and we have the horizontal component of 600. So for the vertical, it is 600. It is a sine function, sine opposite over hypotenuse. So that is 600 sine 45. Now for the horizontal component, it is the cosine function, but either way it will give us the same answer because our angle is 45 if I'm going to use sine 45 or cosine 45. But the correct answer is, since my angle is located from the horizontal, it would be the cosine function. So this is 600 cosine 45. Okay, so summation of moment at A, all forces rotating clockwise should be positive. So what are the forces? We have here the 600 rotating clockwise, so that is positive. So 600 times a lever arm of 600 sine 45 times a lever arm of 2, then 600 cosine 45 rotating clockwise again, so that is plus, times a lever arm of 0.2 meters. Next, we have the 100 Newton force rotating in a clockwise manner. So plus 100 times a lever arm of 5. And next, we have the 200 Newton force. It is rotating in a clockwise manner. So again, that is positive. So plus 200 times a lever arm of 7. And lastly, we have the B vertical, and it is rotating in a counterclockwise. Therefore, it is negative with a lever arm of 7. And that is equivalent to 0. Equate the equation to 0. So we have here 600 sine 45 times 2 plus 600 cosine 45 times 0.2 plus 100 times 5 plus 200 times 7 minus alpha x times 7 is equivalent to 0. B vertical therefore is equivalent to 404.70 newtons. Okay. Next, we can now solve for the A vertical. So A vertical, it would be the summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? So we have here A vertical minus 600 sine 45. Then we have here minus 100 and minus 200 plus B vertical, and B vertical is 404.77 and equate that to 0. So alpha x minus 600 sine 45 minus 100 minus 200 plus 404.77 is equivalent to 0. And A vertical is equivalent to 319.49 newtons. Okay? And lastly, we have the horizontal. So, summation of forces, horizontal, is equivalent to 0. All forces that are pointing to the right should be positive. So, what are the forces? We have 600 cosine 45 pointing to the right, therefore that is positive. So, 600 sine 45 minus B horizontal is equivalent to 0. Transpose this to the other side of the equation to make it positive. B horizontal therefore is equivalent to 600 sine 45, that is 424.26 newtons. And these are your final answers. Okay, so we have here problem number 2. Determine the magnitude of the forces C and T which, along with the other three forces shown. So we have here the 16 kilonewton force, the 8 kilonewton force, and the 3 kilonewton force act on a bridge truss joint. So this is a joint of a bridge truss. So we need to determine the values or the magnitude of forces C and T. So actually we can go directly with our solution, but let's try to redraw our free body diagram. So this is my Cartesian plane. We have here the 16 kilonewton force. So we have here 16 kilonewtons. Then we have here the opposite side. We have an 8 kilonewton force. Then we have a downward force. We have a downward force of 3 kilonewtons. And we have the C declining 20 degrees from the vertical. So this is C, and it has an angle of 20 degrees, and we have a tensile force of force T 40 degrees from the horizontal. Okay, so if you can see, we have here two unknowns and we have three equations. Therefore, we could solve for the unknown. Okay, so summation of forces vertical. So I'll be having here the C vertical, and I'll be having here the C horizontal. Likewise with T vertical, and I'll be having here the T horizontal. So Ty, Tx, we have here Cx, Cy. Okay, but we will not be using them actually because we'll be using the C and the T directly. Okay, so to solve that, we have summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? So we have here, it would be no, it's just the same. We have here for the vertical, we have negative 3 minus cy, and to get cy, since this is my angle, it is cosine function. So cosine 20, and it is pointing downwards, so minus cosine 20 adjacent, that is cy, times is equivalent to cy over the hypotenuse of c. So that is c cosine 20. Then for ty, it is sine function, opposite over adjacent, and it is plus because it is pointing upwards. So sine 40 is equivalent to ty over the hypotenuse of t. And do we still have more? 1, 2, 3, wala na. And that is equivalent to 0. Okay, so one in terms of the other. So I'll be using, let's say, t. So convert, transpose these two terms to the other side of the equation to make it positive. We have t sine 40 is equivalent to 3 plus c cosine 20. Okay, so cross multiply, t is equivalent to 3 plus c cosine 20 over sine 40. And this is my first equation. Okay, now for the second equation, summation of forces horizontal. So summation of forces horizontal is equivalent to 0. All forces that are towards right should be positive. So we have here negative 16 plus 8 plus cx, and cx is sine function. So sine 20, and it is pointing to the right, therefore it is positive. So plus sine 20 is equivalent to cx over c. So that is c plus tx. Tx is pointing to the right, therefore it is also plus positive. So plus, this time it is a cosine function, adjacent over hypotenuse. So that is cosine 40 over is equivalent to tx over the hypotenuse of t. Cross multiply, this would become your term. So we have 1, 2, 3, 4, no more, and equate it to 0. Okay, so I'll be substituting my first equation to my second equation. So we have here sub 1 in 2. So we have here negative 16 plus 8 plus c sine 20 plus t. What is t? We have 3 plus c cosine 20 divided by sine 40 times cosine 40 is equivalent to 0. Input that in your calculator. Negative 16 plus 8 plus alpha x times sine 20 plus 3 plus alpha x cosine 20 divided by 40 sine 40 rather times cosine 40. Equate that to 0, and there we have it. C is equivalent to 3.03 kilo newtons. So substitute this in 1. Substitute in 1. We have T is equivalent to 3 plus the value of C, 3.03 cosine 20 over sine 40. T therefore is equivalent to 3 plus 3.03 cosine 20 over sine 40. And that is equivalent to 9.10 kilo newtons. And these are the two values. Next, we have here problem number T. The box is used to tighten the bolt at A. If the wrench does not turn when the load is applied to the handle, determine the torque or moment applied to the bolt and the force of the wrench on the bolt. Okay, so we are going to consider this problem as a fixed support. Okay, so imagine you have here a bolt and you are to tighten the bolt. Once it is no longer turning, then it is already resisting vertical, horizontal forces and a moment. Therefore, we will be having three forces present. Okay? So if I am to draw my free body diagram, it would look like this. Okay? So we have here the vertical. We will also have here the horizontal, and I'll be having here my moment. Okay, so a vertical, a horizontal, and we have here moment A, and we have here the 52 Newton force, and we have here the 30 Newton force. 60 degrees from the horizontal, and this one we have a slope of 12, 5, and the hypotenuse is 13. Okay, so we can now solve for uh, the moment first, because since we already have one support, we can only have our moment at point A. Okay, so if we will be having our moment at A, we will cancel out a vertical and a horizontal. We can determine the moment at, or the moment A. Okay, so summation of moment with respect to A is equivalent to 0. All forces rotating clockwise should be positive. So what are the forces rotating? So we have MA. MA, I assumed my moment A to be rotating counterclockwise. So that is negative moment A. Then we have here the 52 kilonewton 52 Newton force, and I will only consider the vertical because the horizontal is concurrent. Okay, and the vertical component would be rotating in a clockwise manner, therefore it is positive. So plus 52 times the vertical component of the slope, which is 12, divided by the square root, divided by the, no, not the square root, by the hypotenuse, which is 13. Okay, and next we have here the 30 Newton force, and the 30 Newton force is also rotating clockwise for the vertical. We have here the vertical, we have here the horizontal. This is the vertical, and this is the horizontal. Okay, the vertical would be rotating in a clockwise manner, so that is 30, and it is a sine function. Sine 30, sine 60 is equivalent to the vertical over the hypotenuse, so that is 30 sine 60, and equate this to 0. Then we can now solve moment A. Plus 52 times 12 over 13 plus 30 sine 60 is equivalent to 0. Moment A is equivalent to 73.98 newtons times meter. So that is 73.98 Newton meter. And it is rotating counterclockwise. Therefore, my assumption is correct. Now, for the vertical, we have summation of forces vertical is equivalent to 0. All forces that are pointing upwards are to be positive. So what are those forces? We have a vertical, and the vertical component is pointing downwards, so minus 52. No, our moment is incorrect because we did not include the lever arm. Okay, so incorrect. Let's first solve for the A vertical. A vertical is equivalent to a minus 52 times the vertical component of the slope, which is 12, over the hypotenuse of 13 minus 30, and that is a sine function. So sine 60 is equivalent to 0. Okay, so this is 73. Okay, so I'm right. So this is 73.98, and this is in newtons. So our moment here is incorrect. Rather, let's resolve that. Summation of moment at A is equivalent to 0. All forces rotating clockwise should be positive. So we have here negative MA because I assumed it to be counterclockwise, plus 52 times the vertical component of the slope, which is 12, over the hypotenuse of 13, times a lever arm of 300 mm. So the distance here, we forgot the lever arm because I forgot to include the distance in my free body diagram. So you can see the importance of free body diagram here. So this is 0.3 meters and this is 0.4 meters. So the lever arm is 0.3 plus we have 30 sine 60 times a lever arm of 0.7 meters is equivalent to 0. Therefore, let's just include here 0.3, then here times 0.7. Shift solve. Moment A, MA is equivalent to 32.59 Newton meter. Okay. For the horizontal, it is simply summation of forces horizontal is equivalent to 0. All forces towards right should be positive. So what are those forces? So we have A horizontal is equivalent to, we have 52, the horizontal component of 52 pointing to the left, so that is negative. A horizontal minus 52 times the horizontal component of the slope, which is 5 over the hypotenuse of 13, plus we have here 30 because it is pointing to the right, plus 30, and that is a cosine function. Cosine 60 is equivalent to 0. So cosine 60 is equivalent to the horizontal component over the hypotenuse cross multiply, and that would be the term. So alpha x minus 52 times 5 over 13 plus 30 cosine 60 is equivalent to 0. A horizontal is equivalent to 5 newtons. And these are your final answers. Okay, so we have here problem number 4. Calculate the tension in the cable which supports the 500 kilogram mass with the pulley arrangement shown. Each pulley is free to rotate about its bearing, and the weights of all parts are small compared to that with the load. Find the magnitude and the total force on the bearing of the pulley at C. So we need to determine the tension here, or the weight being carried by this rope with respect to the 500 kilogram force. Okay, since there are no given friction coefficient of friction, we are to assume that all of these pulleys are um, frictionless. Okay, so we can now solve. In doing so, we need to convert the 500 kilogram mass into its weight by multiplying it by 9.81, and that is equivalent to 500 times 9.81 divided by 1000 to make it in kilo newtons. So divided by 1000, that is 4.91. 4.91 kilo newtons. Okay, so isolating our first pulley, I'll be redrawing my first pulley here. Okay, so we have here the 4.91 kilonewtons. Then I'll be having here, let's say this is tension 1 and this is tension 2. Okay, so we have here, let's say, a radius. We do not have the radius of the pulley, so let's say that it has a radius of r, and again on the other side it has a radius of r. Okay, so to have our first equation, because we have two unknowns here, so we'll be using two equations. So let's have our moment at the center. Okay, so let's say that is O. So summation of moment at O is equivalent to 0. All forces that are rotating clockwise should be positive. So what are those forces? So we have T1, and it is rotating in a clockwise manner, times a lever arm of R. Then we also have T2 rotating in a counterclockwise manner, and it has a lever arm of R. So that is minus T2 times R is equivalent to 0. Transposing this term to the other side of the equation, T1R is equivalent to T2R. R will simply cancel out, therefore, T1 is equivalent to T2. Okay? Now, to solve for the value of T1 or T2, we'll be using the summation of forces vertical. So all forces that are pointing upwards should be positive. So what are those forces? So we have T1 plus T2 minus 4.91 kilo newtons, and that is equivalent to 0. But T1 and T2 are the same. Okay, so therefore we have 2 T1, then transpose this to the other side of the equation, is equivalent to 4.91. Therefore, T1 or T2 is equivalent to 4.91 divided by 2, 2.455 kilo newtons. Okay, and this is also equivalent to, this is T1 equivalent to TC, and this is equivalent to TA. Therefore, T1 is also equivalent to TA. Okay, so this is roller A. Now, redrawing roller B, we have here, I'll be redrawing here my pulley B. So we have here, since here the tension is down upwards, I am going to uh, redraw it here in a downward manner, just to cancel out the force, okay, like what we have discussed in the previous discussion. So this is 2.455 kilo newtons, and let's say that this is tension 3 and this is tension 4. Okay, so again, let's say that this is point O. Summation of moment with respect to O, all forces rotating in a clockwise manner should be positive. We have T3R minus T4R is equivalent to 0. R will simply cancel out, therefore T3 is equivalent to T4. Okay, next we have summation of forces vertical equals 0. All forces that are pointing upward should be positive. So what are those forces? So we have T3 plus T4 minus 2.455 is equivalent to 0, because that is pointing downwards. And we know that T3 and T4 are the same. So we have 2 T3 is equivalent to, transpose this to the other side of the equation to make it positive, 2.455. T3 therefore is equivalent to 1.2 0.228 kilonewtons. And T3 is equivalent to this, okay? And this is also equivalent to T3. So this is TB here, okay? No, this is not point C. That is not point C. So this one is point C, okay? So that is equivalent, T3 is equivalent to TC. And this is equivalent to TC as well. So this is the magnitude of the total force on the bearing of the pulley. But if we are interested in determining the X and the Y component, we will be using this force, okay? So if we are to draw that, let's draw our pulley C. We have here the pulley. Then this is 1.228 kilonewtons. And we have here an angle of 30 degrees. So we have here C of X, then we have here C of Y. Okay? So summation of forces vertical is equivalent to 0. All forces pointing upward should be positive. And that is a sine function. So sine 30 is equivalent to C of Y over, so that is sine 30 is equivalent to CY over the hypotenuse of 1.228. So CY is equivalent to 1.228 sine 30 plus or minus, we have there the CX, minus CX is equivalent to 0. Therefore, CX is equivalent to 0.614 newtons. Okay? Kilonewtons. Then summation of forces horizontal is equivalent to 0. All forces to the right should be, no, this is CY. This is CY. CY. CX, so we have here the horizontal component, so that is cosine, this one. Cosine 30 is equivalent to the adjacent, that is CX over the hypotenuse. So 1.228 cosine 30 minus CY is equivalent to 0. So CY therefore is equivalent to, so what is CY? 1.06 kilonewtons. So these are the values. Okay, so I have here problem number 5. The homogeneous plate shown has a mass of 100 kilograms and is subjected to a force and a couple moment along its edges. So we have here a force of 300 Newton and a couple moment of 200 Newton meter, and it is rotating in a clockwise manner. Okay, and if it is supported in the horizontal plane by a roller at A, so we have a roller at A, therefore we will be having one reaction only. Okay, so a roller at A and a ball and socket at joint B. So since we have a ball and a socket at joint B, we will be having 3 reactions. Yeah. So with respect to the 3 dimensions, okay, or 3 axes. Okay, and a chord at C. So we have a chord at C. So we will be having, let's say, tension C. Determine the component of the reaction at this support. Okay, so that is our diagram. So how am I going to deal with that? So I'll be appointing uh, my axis. Let's say that this is my y-axis. This is my y-axis. This would be my x-axis, and here would be my z-axis. We are also given the mass of the plate, which is 100 kilograms. And 100 kilograms is times 9.81 is equivalent to the weight. So 100 times 9.81 is 981 newtons. Okay? So since that is in Newton, we will use the weight in Newton as well. So 981 newtons. And we know that it is located at the center of gravity. So we have it here. We will place it here, the 981 newtons. So it is 1 meter, 1.5 meter, and it is 1 meter with respect to the y axis. The x distance is 1 meter. The y, the distance with respect to y is 1 meter. Okay, so there we have it. So we have here the a vertical or az. We have here the bx. We have here the by, and we have here the bz. So we need to determine the forces. Okay, so we will be using the 6 equations of equilibrium, and that is for the three-dimensional. Okay, so let's start with the summation of forces. Summation of forces along x-axis is equivalent to 0. All forces that are pointing towards the x-axis should be positive. Are there any forces? We only have bx. So from there, yeah, we only have bx. Well, no. Yes, so it is only bx. Therefore, bx is equivalent to 0. Next, summation of forces along the y-axis is equivalent to 0. All forces that are pointing towards that direction should be positive. So what are the forces that are pointing towards that direction? We have by. No, this is moment. That is not a force. So we only have by. By therefore is equivalent to 0. Okay. Next would be the summation of forces along the z-axis. Okay, so this time we will be having forces. So summation of forces along the z-axis is equivalent to 0. All forces that are pointing upwards should be positive. So what are those? We have AZ. We also have BZ. And we have tension C. Okay? Minus 300. Minus 981. And we have 1, 2, 3, 4, 5. And that's it. And equate it to 0. Okay? So this is my equation number 1. Summation of moment with respect to x is equivalent to 0. All forces rotating with respect to the x-axis on a clockwise manner should be positive. So again, if this is my thumb, I'll be pointing my thumb on the direction of the positive x-axis. So the curling of my fingers would be the positive direction. So what are the forces that will be rotating? So 300 Newton here is concurrent with x, therefore we can cancel that out. Okay? And likewise with our moment. Our moment is concurrent with the with axis of x. So I can also cancel this out. So next is the 981 Newton. 981 Newton would be rotating uh, in a clockwise direction, wherein the direction of the positive moment is counterclockwise. Therefore, 981 is in negative. Okay? So we have here negative 981 times a lever arm. The distance from 981 to the x-axis is 1 meter. So times 1. Next, we have here, let's see, BZ. BZ is parallel with x. Therefore, we can also cancel that out. BY is also concurrent with point uh, with x distance. Okay, so we can cancel that out. And we are left with BZ. BZ, in a sense, would be rotating in a counterclockwise direction. And take note that our positive direction is counterclockwise. Okay, therefore BZ is positive. So plus BZ times a lever arm of the distance of BZ to the x-axis is 2. So times 2. And lastly, we are left with TC. TC will also be rotating in a counterclockwise manner, and that is the positive direction. So plus TC times a lever arm of 2 is equivalent to 0. This is a correction. We should remove this because we should follow the right thumb rule. Okay? So there should be no assigned direction. Okay? So that's it. We have two unknowns. So this is my equation number 2. Okay? Next is summation of moment with respect to y is equivalent to 0. Okay. So where is my y-axis? So my y-axis is this. So if I am to point my thumb on the direction of the y-axis, the uh, curling of my fingers would be the direction of the positive moment. So this is my thumb. This is the curling of my fingers. So therefore, the positive direction is on this way. So what are the forces that are going to rotate with respect to y-axis? TC is TZ, and the 200 Newton meter moment is concurrent with y. Therefore, we can cancel them out. Next, we have the 300 Newton. The 300 Newton will rotate with respect to the y-axis in the same manner as the positive. Okay? So it will rotate in a positive manner. So we have there 300. So plus 300 times a lever arm of 1.5 plus 981 times a lever arm of 1.5. By the way, 200 here should not be cancelled out because that is a moment. That is not a force. If you're going to check the rotation, it is rotating in a clockwise manner. Okay? So, clockwise manner with respect to our y-axis. And the counterclockwise manner is our positive direction. Therefore, the 200 Newton meter moment here is negative. So minus 200. I repeat, we should not cancel out the 200 here because that is a moment rotating with respect to the y-axis. Okay, that is a correction. And we do not include a lever arm because that is already a moment. Okay, the next thing that is going to rotate is we have 1, 2, 3. Next, we have the AZ. AZ rotating in a negative direction. So this is the positive. A is rotating otherwise. So that is minus AZ times a lever arm of the distance of AZ with respect to y is 3. Lastly, we have the BZ. Okay, so BZ is going to rotate the same as the same direction as AZ. So that is minus BZ times a lever arm of 3. Meron pa ba? 1, 2, 3, 4, and 5. And wala na. And that is equivalent to 0. And this is my third equation. Okay? Lastly, we have input this equation in your calculator. Okay? So, 3 unknowns, 3 equations. So, we have equation. So, that is A simultaneous equation. Unknowns natin, we have 3. Okay, so first equation, we have 1, 1, 1 is equivalent to 300 plus 981. Then second equation natin, we do not have A, so that is 0. B is 2. C is 2. Then negative, transpose that to the other side, it will become positive, 981. Then we have here AZ, negative 3. B is negative 3. C, we do not have TC, so that is 0. Then transpose this to the other side of the equation, that will become negative 300 times 1.5 minus 981 times 1.5 plus 200. Okay. So we have AZ is equivalent to 790.5. We have BZ. Is it BZ? Yeah, BZ is negative 216.67. And we have TC. TC is equivalent to 707.17. And that is in newtons. So, newtons, newtons, and newtons. Okay? So, AZ here is correct. Our assumption of the direction is upwards. While BZ here is incorrect. It should be pointing downwards. And TC here is correct because it is a rope. Therefore, it should be in tension. So, it should be upwards. So, that is 707.17 newtons. And that is, this is our answer. So, solve 3 equations simultaneously. Okay. So we have here a frame, and we need to determine the resultant forces of pins B and C on member ABC of the 4-member frame. Okay, so this is the 4-member frame: AC, CD, DE, and BE. So we need to determine the forces acting on B, BE, and CD. So if we are to redraw our free body diagram, it would look like this. Okay, so you have here a vertical, you have here your a horizontal, and you have here your moment A. Then you have here the loadings, the uniformly distributed load. Okay, and it is 7 feet, and it is 150 pounds per feet. Okay, so we have here BE. BE is inclined in such a way that it is 5 minus 2, it is 3 for the horizontal. Then it is 4 for the vertical. Okay, so this would be the free body diagram. So we have here 3 is the 4 over the hypotenuse of 5. Then we have here CD. CD. So this is how CD would look like. Okay. So that would be for member AC. Now for member FD, it would look like this. So we need to redraw our free body diagram. We have here this is BE. This is also BE, and CD would look like this. Okay, and we have here no, it is a pin support. We do not have any moment at pin support, so we do not have a moment at pin support. So okay, so let's change that into pin. Okay, so we have two unknowns and we have three equations. Okay, so let's start with this. So summation of moment, I'll be having my moment at point A, so that I will no longer solving for AV, AH, and I'll be having my unknown as BE and CD. Okay, so summation of moment at point A is equivalent to 0. All forces that are rotating clockwise should be positive. So what are those forces? We have negative, or let's start with the load. So we have here the load. The load here is 150 times a lever arm of 7 times times a span of 7 feet times a lever arm of 3.5. Take note that the center of gravity for a uniformly distributed load is acting at the center, and the center of 7.5 is 3.5. So 3.5 to point A, center to point A is 3.5. Therefore, the lever arm here is 3.5. Then we have here BE. BE is BE vertical is rotating counterclockwise. But for BE horizontal, it can be cancelled out or neglected. Why? Because it is concurrent with our point A. So it is only BE vertical. So BE vertical is rotating counterclockwise, so that is negative. Negative BE times the vertical component of the slope, which is 4 over the hypotenuse of the slope, which is 5. Last times the lever arm. What is the lever arm? The lever arm here is 5. Okay. Next, we have CD. CD is rotating counterclockwise, therefore it is negative. So negative CD times a lever arm of 7 feet is equivalent to 0. So this is my equation number 1. Okay. Next, for my equation number 2, I'll go to member FD. So summation of moment with respect to F. So this is F, this is D. With respect to F is equivalent to 0. All forces that are rotating clockwise should be positive. So what are those forces? Okay. BE would be rotating in a clockwise manner. BE vertical component. For the horizontal, again, it can be neglected. So we have here 4, 3. Okay. So we have here BE times the vertical component of the slope, which is 3 over the hypotenuse of 5, times a lever arm of 2 feet, times 2, plus CD, rotating clockwise, therefore it is positive, times a lever arm of 7 is equivalent to 0. So this is my second equation. So solving simultaneously, or you can simply input that in your calculator, but let's try to simplify. So we have here, transpose this to the other side of the equation to make it positive. So we have here 3 times 2 divided by 5. That's still 6 over 5. So we have here CD is equivalent to negative 6 over 5 BE divided by 7. So substitute this. So this is our equation 2. So substitute 2 in 1. So our first equation, we have 150 times 7 times 3.5 minus BE times 4, because 5 will simply cancel out there, minus CD. What is CD? We have negative 6 over 5 times BE over 7 negative times 7, because we have 7 there. So 7 will simply cancel out, and that is equivalent to 0. So 150 times 7 times 3.5 minus alpha x times 4 minus negative 6 over 5 times alpha x, and that is equivalent to 0. So it is 1,312.5. But I think we had an error here. Why? Because this should not be the answer. Let's check a moment at F. We have BE. Ayun. So this is the error. This should be 4, not 3. So vertical component of the slope is 4 over the hypotenuse of 5. Okay? So that is, this should be 8. So this is 8. So okay, so this is the answer. So BE is equivalent to 1,531.21 pounds. And substituting this value, so sub into, we can now have our CD. So CD is equivalent to negative 8 over 5 times 1531.25 divided by 7, and that is negative 8 over 5 times alpha x, 1531.25 divided by 7, and that is negative 350, and that is in pounds. So that is equivalent to 350 pounds. And our assumed direction for CE, where is CD? No, this is not CE. It's equivalent to CD. Our assumed direction for CD is incorrect. So it is otherwise. So these are the final answers. Okay, next problem. We have here a rope problem. So determine the tension in each segment of the cable shown. So we have here the cable AB, BC, CD, and DE. So you have force at B, force at C, and a force at B. So the first thing that we need to do is to determine to draw our free body diagram. So drawing our free body diagram, it would look like this. Okay, so we have here, a horizontal. We have here a vertical. We have here and there E vertical. Yeah, E. No, E horizontal, then E vertical. Then we have here force of 4 kilonewtons. We have here 15 kilonewtons. And we have here 3 kilonewtons. Okay. So this is how my free body diagram would look like. Okay, so we can now start solving. So summation of forces horizontal is equivalent to 0. All forces that are pointing towards the right should be positive. So what are those forces? So we have here A horizontal and E horizontal. So E horizontal minus A horizontal is equivalent to 0. Therefore, A horizontal is equivalent to E horizontal. Okay? So next is solving for the Y. A vertical and E vertical. Okay? So magka-level yan. They are leveled na sobrahan lang. So summation of moment at point A is equivalent to 0. All forces that are rotating clockwise should be positive. So what are those forces with respect to A? Okay? So we have here 4 times a lever arm of 3 plus 15 rotating clockwise. So that is positive times a lever arm of 8. Then we have the 3 kilonewton. Again, it is positive because it is rotating clockwise times a lever arm of 16. Okay? Then we have here the E vertical. E vertical is rotating counterclockwise. So that is minus with a lever arm of 18. And that is equivalent to 0. So 4 times 3 plus 15 times 8 plus 3 times 16 minus alpha x times 18 is equivalent to 0. And that is 10. E vertical is equivalent to 10. Next, summation of forces vertical. Summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. What are those forces? So we have A vertical minus 4 minus 15 minus 3 plus 10. And that is equivalent to 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A vertical therefore is equivalent to 12. And these are in kilonewtons. Okay, so we can now start solving for the tension on each cable by drawing the segment. Okay, each segment. Okay, so let's start with segment BC. Bakit tayo nag-start sa segment BC? Why are we starting with segment BC? Because if we are going to cut at segment AB only, if we will be having a moment, then it's either A will cancel out or B will cancel out. We cannot get something. But if we're going to start with segment BC, if we are going to have our moment at point B or point C, we can solve at least a value. Okay? So let's say I'll be having my moment at point C. So summation of moment at C is equivalent to 0. All forces that are rotating clockwise should be positive. So what are those forces? So I have here 4 kilonewton rotating in a counterclockwise, and that is negative times a lever arm of 5 meters. Okay? Next, BC here is concurrent with point C, therefore it can be cancelled out. Okay, so we are left with AX or A horizontal. So for A horizontal, it is rotating again in a counterclockwise manner. Okay, so we have negative A horizontal times a lever arm. Take note, the lever arm here is 12. So times a distance of 12. 12 meters. So we have here a lever arm of 12. And we have here the 12 kilonewton, and it is rotating in a clockwise manner. So plus 12 times a lever arm of 5 plus 3, that is 8. And equate it to 0. So we have 1, 2, 3, 3 forces present. So we have negative 4 times 5 minus alpha x times 2 plus 12 times 8 equated to 0. Therefore, it is, wait, this should not be 2, it should be 12. Okay, so a horizontal is equivalent to 6.33 kilo newtons, and a horizontal is equivalent to E horizontal. They are the same. Of course, it is in tension. Okay? So, next would be the summation of forces horizontal and the summation of forces vertical. In doing so, we can solve for the tension BC. So, we have here tension BC. Okay? So, summation of forces vertical is equivalent to 0. All forces pointing upward should be positive. So, what are those forces? We have 12 minus 4 minus tension BC times the vertical component. So what is the slope here? We have 5 is to this distance here, but it would be very difficult if you will be using the slopes, so let's use the angle. Okay, so for the vertical, it is the sine function. So sine theta, and that is equivalent to 0. So we have 1, 2, 3. Okay, so this would be my equation number 1. Summation of forces horizontal is equivalent to 0. All forces that are pointing towards right should be positive. So we have here a horizontal that is negative 6.33 plus TBC cosine this time. Cosine theta because it is adjacent. The angle is adjacent to the side. So cosine theta is equivalent to 0. And this is my equation number 2. Solving simultaneously, we have here T is equivalent to 10.2 kilonewton, while theta is equivalent to 51.6 degrees. So this is TBC. These are the values. Next would be the free body diagram of joint A. Okay, so for joint A, so we have here the free body diagram of joint A because I can now solve for my tension at AB. This is tension AB because I already have the value for AX. I'll be having two unknowns here, tension AB and theta AB. Okay, so summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So I have here 12 minus TAB, and for the vertical, it would be the sine function, opposite over hypotenuse. So that is sine theta AB is equivalent to 0. Okay, so I'll be looking here for theta in terms of TAB or opposite. So it would be cross multiply this to the other side of the equation to make it positive. So we have TAB sine theta AB is equivalent to 12. Okay, so TAB therefore is equivalent to 12 over sine theta AB. Okay, next would be summation of forces horizontal is equivalent to 0. All forces towards right are positive. So we have negative 6.33 here, plus TAB. This time it is a cosine function adjacent. So cosine theta AB is equivalent to 0. This is my equation 1 and this is my equation 2. So we have here sub 1 in 2. Okay, so substituting, we have here negative 6.33 plus TAB. No. What is TAB? TAB is 12 over sine theta AB times cosine theta AB is equivalent to 0. So input that in your calculator. We have negative 6.33 plus 12 over sine alpha x times cosine alpha x is equivalent to 0. Then theta AB is equivalent to 62.19 degrees. Okay, so substitute this value to your first equation. TAB therefore is equivalent to 12 over sine 62.19, and that is equivalent to 13.57 kilo newtons. Okay, next would be joint C. Okay, so for take note, here we already have our angle here, and that is 51.6. So the angle also here is 51.6. So if we are to have it at joint C, we can now solve for tension CD the same time with the angle CD. So drawing the free body diagram, it would look like this. Okay, so summation of forces vertical is equivalent to 0. All forces that are pointing upwards should be positive. So we have here 10.2, and this time it is a sine function. So sine 51.6 minus 15 plus we have here TCD. TCD vertical, so that is again sine function. So TCD sine theta CD is equivalent to 0. And this is my first equation. Next, we have summation of forces horizontal is equivalent to 0. All forces to the right are positive. So we have here 10.2, and that is negative because it is pointing to the left, and since it is the horizontal component, it is a cosine function adjacent. So cosine 51.6. Then we have TCD positive because it is to the right, so plus TCD cosine of theta CD is equivalent to 0. So transpose this to the other side of the equation to make it positive. TCD cosine theta CD is equivalent to 10.2 cosine 51.6. Then we have here TCD is equivalent to 10.2 cosine 51.6 over cosine theta CD. And this is my equation number 2. So substitute equation number 2 in equation number 1. We will be having negative 10.2 cosine 51.6 plus, what is TCD? We have here 10.2 cosine 51.6 divided by cosine theta CD times we have here no, error, no, it this is not, it is this one. This is our first equation. Okay, so we have here 10.2 sine 51.6 minus 15 plus what is TCD? 10.2 cosine 51.6 over cosine theta CD times sine theta CD is equivalent to 0. CD therefore is equivalent to 10.2 sine 51.6 minus 15 plus 10.2 cosine 51.6 over cosine theta CD sine alpha x is equivalent to 0, and that is equivalent to 47.88 degrees. So substitute this to our second equation. TCD is equivalent to, what is the value there? 10.2 cosine 51.6 divided by cosine of 47.88 degrees, and that is equivalent to 9.45 kilonewtons. And with that, we can now solve using the we can now solve tension DE by having the moment, the joint, the free BD of joint E. Okay? Or we can solve tension DE by simply using the joint E. So this is joint E. The forces present are, you have here the E vertical, the E horizontal, and you have tension DE. Okay, so eliminating so many variables, so that would be easier. So summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So we have here 10 minus TDE, and for the vertical it is a sine function, opposite. So sine theta DE is equivalent to 0. Okay, so this is my equation number 1. Next, summation of forces horizontal is equivalent to 0. All forces towards right should be positive. So I have here 6.33 minus TDE, because TDE is pointing to the left, and since it is the horizontal component, we're going to use the cosine. So cosine theta DE is equivalent to 0. Transpose this to the other side of the equation to make it positive. So TDE cosine theta DE is equivalent to 6.33. So TDE is equivalent to 6.33 divided by cosine theta DE, and this is my equation number 2. So substitute sub 2 in 1, we will be having positive 10 minus what is TDE, 6.33 divided by cosine theta DE, then here we have sine theta DE is equivalent to 0. Therefore, theta DE is equivalent to over cosine alpha x times sine alpha x is equivalent to 0. Shift solve. So you have theta DE as 57.67 degrees. So substitute theta DE, we will be having tension DE. So what is our equation for theta DE? for TDE, we have 6.33 divided by cosine 57.67, and TDE or tension DE is equivalent to 11.84 kilo Newton. And these are your final answer.